Now that we know about pressure systems and winds, we are going to talk a little bit about the water cycle and water within the atmosphere as we get further into actual weather events. So the water cycle is something that you all should be very familiar with from middle school, but I thought maybe we could use a little bit of review. So take a second, and I just want you to think of some of the different parts of the water cycle and where they would fit within this diagram. So take a moment and you can talk with your group, and then I will come back and we'll finish reviewing the water cycle. Okay, so one of the things that hopefully you remembered is precipitation. That's probably the easiest one and most memorable one. So precipitation we could draw such as rain coming down. Then how does that rain get into the atmosphere in the first place? Well, other than precipitation, it gets there because you have evaporation. So that is your evaporation. That's the water going into a gas back up to the clouds. You also have the water that is going down the stream. That would be called runoff. And then you have water that is leaving the trees, and that is going to be your transpiration. Now, as this water down here evaporates and as the water from the tree transpirates, then what process does it go through to make this cloud? Well, that is condensation. So the clouds are undergoing condensation. So hopefully that rings a bit of a bell for you, and you can remember a little bit more of the water cycle. That's about all the review that we will do with it. So there's another diagram if you need to see it. So what is the water cycle? Well, the water cycle is just where water circulates between the ocean's atmosphere and land, and it involves all three of the water phases. So just like cycle makes you think, it's just going back and forth. So the water you have on the ground was once in the sky, and once it's on the ground, it's going to go back up into the sky, eventually back up into the atmosphere. The water that's on the land, if it doesn't go to the atmosphere first, will eventually make its way into rivers and oceans. So it's always constantly going around and around and around. And the way it can do that is because of the three phases that water can be in. Water is very unique in the fact that it's one of the very few materials that exist in all three phases. Now, what are these three phases? It's a solid, liquid, and a gas. So solid water would be ice, liquid water is just water as you would drink it, and then gas would be like the water vapor that's in the air that's all around you, but you can't even see it. Or sometimes you may see it when it's foggy outside. So because water can go into all those three phases in very natural conditions on the earth, that's why we have the water cycle, and that's also a really big reason of why we have life. So as you get into chemistry and you learn more about the properties of water, you're going to see just how unique it is and why it's such a big deal to find it whenever you're looking for a source of life somewhere. Okay, so we will continue. So water changes from a solid to a liquid through, if hopefully you can remember this, but it's going from a solid, that would be ice, so then to a liquid, it's going to do that through melting. And sorry, I think there's a bit of a delay in the screen there, but it goes from a solid to a liquid through melting. And don't write all of these down. If you know them, skip it. But if there's one of these words that as I'm explaining it, you forgot what it was, then write that particular one down. So solid to a liquid through melting. It goes from a liquid to a gas through evaporation. From a gas to a liquid through condensation, and from a liquid to a solid through freezing. Actually, I have all these typed out, so let me put those up for you. So melting, evaporation, condensation, and freezing. These are what we call a phase change. So it's how it goes from one phase, such as a solid to a liquid, to another one. So these are the processes that phase changes occur. And again, if you don't know a particular one, then focus on writing down that one A lot of these you probably do know. Hopefully you know that to get from liquid water to solid water, it will freeze, or from solid water to liquid water, it will melt. Usually the one that students struggle with the most is condensation, gas to a liquid. But if that's the one you need, then make sure you do get that and put a star next to it so that you can focus on studying that. So I'll let y'all pause the video if people still need to write. Otherwise, I am going to continue moving forward. A lot of you may already remember all of this from middle school, and if so, that is just lovely. Let's carry on then. So why is water vapor important to the environment, and what does it do? So I want you to take a moment and pause this video and talk about that in your group. So why is water vapor, particularly vapor, important, and then what does it do within the environment? Okay, so we're going to look at some of the ways water vapor is important within these next few slides. So what is water vapor? Again, don't write this if you don't know it, but all that water vapor is water in gas form. If you look around, again, you're not going to see it, but there's water vapor surrounding you right now. Water vapor is in the air, especially if a lot of times there's water vapor in the air and you don't even realize it, but you would really notice it if it's humid. So Greenville has very hot, humid summers, and you can feel that water vapor. You can also see some of the water vapor or evidence of it moving through the sky when you look at clouds. So the source of water, or the source of all clouds and precipitation is water vapor. So this is why it's important. If we did not have water vapor, we could not have the water cycle. And with no water cycle, you would get no clouds and you would get no precipitation. So then think about if we use up all the water, or if our water just sunk deep, deep into the ground, we would run out of water because it wouldn't ever come back and be replenished. Also, all the plants would not get watered. So the fact that we have water vapor, precipitation, cloud coverage, all of those things, they're very, very important to keeping life moving. Remember, the Earth, and not only Earth, but all of science is a system. So if you impact one part of a system, it's going to affect all the rest of the parts of the system. So if you got rid of water vapor, that's a very key element of the system of life, and that would then, therefore, affect everything else. So water in the atmosphere, don't write this down, but as we talk about weather, it's very important to understand water vapor, because that's one of the most important things when we are actually looking at weather, because weather involves water vapor in almost every way. So what temperature of air can hold the most water? I want you to just think about this for a second. What temperature of air can hold the most water, and why do you think that? Now, I'm not talking about specifically 42.5 degrees, but I'm just talking about warm or cold air. So take a moment and think, which one do you think will hold more water vapor, warm or cold air? Okay. If you said that you thought in your head that you think warm air can hold the most water vapor, you are correct. So the warm air. So I'll just put warm. And the reason being, when air gets warm, what does it do? It expands. I told you that we'd keep coming back to this concept because it's super important. So if this is warm air, all those molecules have spread out and expanded. So then if you have water vapor, this water vapor is going to be able to go in, and you're going to fit tons of little water vapor gas molecules all throughout. There's lots of space for this water vapor to fit. Now, I'm not going to fill in all this because that would be super annoying and take forever, but you could imagine I could go back and just add in tons and tons and tons of little water vapor droplets all throughout this air. However, if I had cold, dense air that comes together, I'll just make a little thing of it here. Because those air molecules are so close together, I'm not going to be able to fit nearly as much water vapor in between them. So warm air holds more water vapor because it expands. And if it expands and spreads out, there's more room for water vapor to fit between air molecules. Cold air gets really close together, it condenses, and because it's so close together, there's just not enough room for water vapor to fit between it. So warm air does hold the most water vapor. And I believe I have that on the next slide. So this is what you write down. So warm air can hold more water vapor than cold air. Make sure you have that written down. Also, make sure that you understand why that is. This, like I keep saying, we're going to keep coming back to this concept. It's going to follow us for humidity, which we're going to get to in just a little bit. It's going to follow us into dew point for lots of different weather events. You need to understand the hot air expands, making it less dense, and it rises. Cold air condenses, making it more dense, and so it sinks. But because it expands, it will hold either more water, or because it condenses, it will hold less water. So that's very important to make sure you know. So moving on, warm air holds more water vapor than cold air. Dew point. Look how beautiful this dew is. Now, I don't know about y'all, but I hate spiders, and I don't want to walk through a spider web. But the spider webs are very pretty, in my opinion, when it comes to them having little morning dewdrops on it. And so is the grass. These are some cool pictures of dew droplets. Now, another area you may have dew would be on your cup. And usually if we have dew on our cup, we usually call that either condensation, or we would say that the glass has sweat. That's kind of how we look at it. But it's the same process occurring on a cold drink versus on the grass or these spider webs. Usually you find dew late at night or early in the morning. And why is that? Well, at nighttime and early morning, the temperature is lower. So the temperature has cooled. So think about it. You have a hot summer day. You have all of this air that's nice and expanded, spread out, and it's holding water vapor. Well, as it gets colder throughout the night into early morning, those water molecules are all condensing, and they're getting closer and closer and closer and closer together. Now, there's still water vapor in there. At some point, those air molecules get so close, there's not enough room for that water vapor. So that water vapor has to leave the air. And the way it does that is it switches from a gas form into a liquid form, and bloop, out comes a little dew droplet. So you've got warm air that's very spread out, and it's cooling. And as it cools, it reaches saturation. And all that saturation means is that it's completely filled, so there's no more room. And so all the air can do is get rid of the water vapor within it. And the way it does that is by just bloop, out comes the liquid water drop, and bloop, 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 all over the grass and the spider webs. You now have dewdrops. So that is what dew point is. The temperature the air has to be cooled to reach saturation. But cool, or becoming colder, is the key here, because the reason it's reaching saturation is due to it condensing. Get it? Due to it condensing. So the smaller that air gets, the less it can hold, and it's got to get rid of something. And so the water vapor is what it gets rid of by transferring it into a liquid form. So that is what dew point is. So this is what I was talking about with a glass of iced tea. So if you have a glass of iced tea sitting there and it's a warm day, then all of the droplets on this cup, they are not coming from what's inside of the cup. They are coming from the air. And why is that? Well, your very cold cup of iced tea has caused those air molecules closest to the cup to condense, and they're saturated. And because they're saturated, they get rid of the water vapor by making dew droplets. And so we say the glass is sweating. No, dew has formed. And all that dew is the process of condensation, because the air has reached saturation due to it being cooled. So that's what's going on with your cup. That's why if you have a room temperature cup of water, you're not going to get any condensation on it. It's not cooling the air to make it reach saturation. And that's why a cup of hot tea is not going to do that either. It has to cool it, and that's what causes saturation to hit. And that's what then makes all the little droplets come out. So now we're going to take a brain break, and we are going to play hot potato. And I have a video that has consistent stops built in, so there's no favoritism. So everybody can stand up, get in a circle. When you play hot potato, you're going to toss the ball, toss the ball to the person next to you, and you're just going to keep going next to you, not across the room. So just toss it to the person directly next to you. If the ball leaves your hands, and then the music stops and the other person hasn't called it yet, you're out, okay? And then when you're out, you just have a seat. If you end up tossing the ball to somebody and you spaz out and it's a bad throw, and they don't get it in time when the music goes out, that's your fault because you didn't throw it well. So don't spaz out. Just calmly toss the ball to the person next to you, and then whenever the music stops, if it was you, you're out and you can have a seat. And the winner gets candy, because I love bribing you with candy. So go ahead and pause this video while you play hot potato.